So welcome everyone, my name is Jackson Ainsworth. I am the Communications and Policy Lead at Boltzmann Institute at Ontario Tech. We have Michael Wiggin here today, who's been working in district heating for quite a while. He's worked in research and development at places like Natural Resources Canada and the International Energy Agency. But I think we'll start and talk about your work with the Boltzmann Institute and what you've been doing recently with respect to thermal energy and district heating.
Yeah, sure, Jackson. A while back, over the years, you develop a network of people of all ages, all backgrounds, and I'm starting to appreciate how important that is, to keep your friends, keep your contacts. Because a little while ago, the government, they saw today's price of electricity, today's emission factors in Ontario, and they said, electrify everything, right? And I agree mostly where you need power, but a few of us were concerned that they were talking also about building heating. And we found a lot of the electrical people didn't really know what they're getting into, because building heating is very peaky during the winter, but it drops off a lot. So in terms of if you had heat capacity, it's only used about 25% of the time. And if you had heat pumps, you still need the same peak capacity, but you may only get about 10% utilization. So we started getting really worried, because if you talk to a nuclear or electrical utility specialist and say you're going to build out to suit heating loads, but if you electrify, you may only get about 10% utilization of your investment, okay? Currently, Ontario Hydro, the Ontario system, the utilization is about 67%. So if you were to drop it down much, prices go up. And we've had some really well-qualified people that advise the government that verified that. So anyhow, we had several people that were concerned about this and concerned about alternatives. So we had worked together before, myself, thermal background, other people, nuclear plant design, operation, nuclear plant troubleshooting, electric, Toronto Hydro, managing district heating systems like Bruce Nuclear Industrial Park, and other guys in the investment real estate community. So we got together and we thought, we're not going to get far if we talk about seven old guys think. So we thought we better make it a little more respectable. So we created what we call the Boltzmann Institute. And then we started, so that's what we did, with the common goal of being broad in our outlook to avoid harmful emissions from the use of energy. That's the general mission we have. But that quickly drew us into thermal energy networks, both the network district heating systems and energy storage. And obviously that brought us into CHP, or combined heat and power cogeneration, okay? So then with that, we entered into discussion with people, electric sector, heat sector, and we grew confident that this was, our point of view was valid, because all the electric people, they anticipate electric prices going up, great pressure on the electric system, but because they operate within an electrical mandate, they don't necessarily think outside the box to other ways to deal with it, okay? So we were successful in, through the Net Zero Advisory Board, in getting a contract, about $750,000. We didn't use that ourselves, it was flow through. We already have 10-year pensions, so we flowed it through to consultants, universities, to do the work, and we produced what's called Two Pathways Report. So anyhow, so what we're finding is we're filling a gap in some of the activities that are often more specialized, electric only, heat only. We're trying to create interfaces, also thermal energy planning and other stuff. So anyhow, so that's kind of the Boltzmann Institute. So now we're at a bit of a crossroads. We've done this major project, and we're saying, what next? First of all, we're not spring chickens anymore, and so we're really focusing on generational transition, pass the torch. So this is why I was especially appreciated the option to come here today to try and create some awareness and excitement about this, and then hopefully to follow up with work on perhaps course material, research focus, or whatever, because we need the young people of the world to start thinking about this. We got some old retired guys think about it. Now we got to bring that out to the world. Anyhow, so that's why I'm so happy to be here, and that's what the Boltzmann Institute does. Yeah.
That's great. And for the people who have read or heard about the Two Pathways report,
Yeah.
maybe you could talk a little bit about the findings in that report, and then maybe some technological advancements
Yeah.
that have happened recently in respect.
Okay. Yeah. Okay. Thanks. I'd love to do that, Jackson. Well, first of all, there's this comparison if you were to electrify building heating, or if you were to find some other way of meeting it. Okay. And so basically, the proposal we created was basically entitled "What We Do Down Two Pathways." Yeah. If we take the electric route, probably heat pumps, air source heat pumps in urban areas, and build the electric system improvements, generation, and distribution upgrades. That's one pathway. The other pathway is creating a thermal network that can take heat from multiple sources. It might be waste heat from industry, like Hamilton. You could heat downtown Hamilton with some of the steel mills. It might be energy from waste plants, like they have here in Durham region. It might be biomass plants. Some parts of the province, they've got way more wood left sitting in the forests than they need to create energy. So we're looking at this for Ottawa. So the Two Pathways study looked at these different possibilities, and they looked at consulting with electrical people, what would it cost if we were to electrify? Oh, I should mention, in Ontario, the peak load for electricity now is 23 gigawatts. The peak load for heating on natural gas is about 85 gigawatts, okay? Bit of a difference. So when you adjust for efficiency of gas use in furnaces, the actual heat demand is, let's say, 70 megawatts, okay? So if you're going to build out your electric system to pick up 70 gigawatts, when you've already got only 23, that's monumental. Just having the capacity to design, build it, never mind the cost, it's out of this world. And whereas the other option would be to evaluate the cost of a district heating system, thermal network, to pick up heat from the existing power plants and other sources. And so that's what we did, and we hired specialist consultant in thermal networks. We got one of the leading ones in North America, FEB Energy. They looked at the thermal part. We took a hypothetical city, it was basically Barrie, with a fair mix in densities, and priced out what it cost, low density networks, high density parts, averaged it out, and we developed a costing model we could apply across the province. Okay? And what we found is about 70% of buildings, the more dense areas, could be served by thermal networks at roughly a cost of, let's say, $4,000 a kilowatt or less, okay? But if you were to upgrade the electrical system, it costs you at least $2,000 for the distribution network, a kilowatt, and somewhere around IESO uses a figure about $10,000 a kilowatt for generation, okay? So you've got maybe $4,000 thermal networks versus 12, roughly, for electric upgrading. People don't understand that if you were to double or even 50% more heat load supply, electric load, you're not just changing a few wires here or there, you got to almost replace the distribution infrastructure, substations, transformers, wires, the whole thing. And then building double or more our existing electric capacity, it's a challenge. People don't understand that implication. Everybody's looking at today. They're not looking down the line 20, 30 years to see what we go with. So based on some of my past work with the GVRD, the Greater Vancouver Regional District, we did a sustainable development plan for 100 years ahead, okay? But what was really neat about that was that if you talk about change now, everybody protects their self-interest. But if you talk about what the future could be 100 years from now, people loosen up a bit. And then when you see all the students and young people getting really creative with mind-blowing ideas, and then the old guys, the planners and the energy experts, hey, we can contribute, we don't want left out. So we got them engaged, and they started talking about the 100-year vision. And before you know it, they developed a powerful vision of the future. And then the next challenge is, okay, how do we get there? What is the locus? What is the pathway to get there? So this is what we need to do more of in Ontario. Everybody's talking about election cycles, 4 years, or protecting their existing assets, and getting comfortable stepping out of the box. So I really think if we take a different view of the future and how to do it, it'd be different. So basically that's what we did, kind of sort of in the two-pathway study, is we found out that it could be maybe about half the cost to hook into existing sources of heat and new renewable sources, whether solar, thermal, wind, or whatever else, tie into that, instead of building more electric capacity to put in electricity. I think people in thermodynamics get really worried when you start using power. Electricity is great for power, but you don't want to waste it on heat. There's lots of other ways to make heat. And heat can be stored for months at a low cost compared to electricity. You can store it for, days or, hours, days, or whatever. So the technology is different. The costs are completely different. Thermal storage, about 2% of electrical storage. So that if we can just open our minds to finding out how utilities interact, then we may come up with something that's much more affordable for the future. Keep electric prices down or lower them, and so forth. So anyhow, that's kind of what we found out of the two pathways study.
And in the spirit of that, I think the technical details of the report often come in contact with the cultural reality of our policy at the moment.
Yeah.
So I wonder if you could speak to the Canadian policy culture around energy and how that may impact the findings of this.
Yeah. I have worked a lot with other countries through the IEA. I was the chair for a while of the International District Heating and Cooling Technology Collaboration Party. Big name, but anyhow. But that gave me the possibility of contacting people in Scandinavia, Germany, China, Japan, Korea, and see the different ways they look at things. And what I found is we are much more segregated. We got electric people doing electricity, thermal, buildings, environment, and they don't talk to each other enough, right? So based on today's electric prices, today's emission factors, they said, oh, wow, electricity, electrified building heating. I mentioned that before. And so this has found its way into policy, so that now both the federal and the provincial governments are promoting electric building heating. Even in provinces like the Atlantic provinces, where most of the electricity comes from fossil fuel, if you put in a heat pump, sounds good, seasonal COP of 2.4, but the electricity comes from something with an efficiency of about 33%. So you get 1/3 of the energy put in comes out of electricity, and take 1 unit and bump it up 2.5. So you actually end up using more fuel to make the electricity than they're using already to run their oil furnace, okay? But they still give you $5,000 or whatever, or more, to put in a heat pump, okay? Now, please don't think I'm against heat pumps. I'm just saying you've got to do life cycle analysis. And this is really important for all our upcoming engineers and people, policymakers. If you just look at the surface, electricity, COP 2.5 or whatever, and make heat, wow, that's a miracle. But if you do life cycle costing, it gives you very different conclusions, okay? So I really would emphasize that in working with all your students, all your upcoming people, policymakers, to get them tuned into life cycle thinking, full cost accounting, life cycle analysis, and you'll come up with something different. So we end up in a position where federal, provincial governments are promoting electrification of heating. The electric utilities are kind of worried about it. Ottawa Hydro said we're facing unprecedented investments to meet soaring electric demand. And then IESO, who's responsible for the planning of electricity, in their outlook to 2050, they allow for about 8% of buildings to be served with heat pumps, okay? Because they know it would be too expensive. They know the challenge of generating the capacity ain't there, right? So we've got the provincial and federal governments promoting one thing, and then ISO saying, we're not too sure. But meanwhile, we're planning all kinds of things, nuclear power plants, everything else, at an incredible rate, and nobody's stopping to say, wait a minute, guys, maybe this is going to do something you didn't think about, maybe there's another way of doing it. So I guess that's where we're at now. So we've got the technical and economic potential to do something different is here. The example is all over the world, like over the Chinese, all Northern Europeans. We don't talk to the Russians much these days, but they've done a lot of this as well. And so the examples are there. The technology risk is zero. The economic value is there, but the comfort is not. So now we're in a position, you've got all these decision makers that are not familiar or not comfortable with the broad array of options that they've got. And we have to make them comfortable. We have to be on their back, making them know somebody's looking at them. Scare them a bit. We see what can be done, and the minister might get asked one day, what about this? Why aren't you doing it? And they're going to have to answer. So that's why it's so important for outreach, so we can talk to as many people we can, get them to kick the tires, disagree, put up arguments, because we've all got to come to an agreement about that powerful vision of the future that we can work toward, okay? And so we got a big challenge.
Oh, that's great.
Yeah.
I wonder if we could change tracks and talk about industry a bit. Mm-hmm. In our previous discussions, you brought up sector coupling.
Yep.
I wonder if you could talk a little bit about sector coupling in terms of both efficiency and economics.
Yeah, okay. Sector coupling, that is becoming a really big thing these days. It's one of the big priority areas for the European Commission and for most of the EU governments. So sector coupling means looking at your electricity system and saying, what is it that's going to make that more expensive? It might be excessive growth, it might be a drop in utilization rates, or whatever. There's a lot of other things. How you cope with load management, short-term fluctuations. So look at your electric system and say, what is it that's going to drive prices up? And then say, what is it of these things should we focus on to maintain affordable electricity in the future? And then the next step, this is where the sector coupling comes in, sit down with the thermal people and say, if you had thermal networks, the capacity to distribute heat, if you had the capacity to link these cooling or heating to buildings, coupled with thermal energy storage, how would that manage our loads? So even if you were using electricity for heating and cooling, well, you will use it for cooling, how could you manage that better, taking into account the thermal network, thermal energy storage? And so what we found, there's a lot of ways that they, if they're coupled, you could do a lot better. The most obvious is CHP, combined heat and power. You have the option, if you were to electrify, of let's say you need another 1,000 megawatts of heat load that's going to be electrified, you got 1,000 megawatts of generation to build. And then Pickering is going to be about 2,100 megawatts when it's built out. So you could either, and then the heat from 2,000 megawatts is roughly 4,500 megawatts. And we're dumping that in the lake, right? You could modify the plant a little bit, extract at a higher temperature, and instead of rejecting at 25 Celsius into the lake, you could take it out at 100. And the loss would be very small. You get about 1 unit of electricity lost to make 8 units of this heat useful, right? So here we are sitting on power plants, Darlington, Pickering, Wesleyville, that every time you build 1,000 megawatts, you're throwing away 2,000 that could be useful, right? So this is the big thing. So sector coupling, and then the other thing I should mention is things like solar thermal. You get great output all year round, but especially in the summer, but you don't need it in summer, right? What they're doing in Europe, they've got whole towns served with solar thermal, and they put thermal energy storage underneath so that all summer they're pumping out heat that would otherwise go to waste and putting it down in thermal storage. Winter comes, they've still got some heat from the solar collectors, but they can take the heat back out. And some of them, they do things like have a small biomass plant as well, so that if they need extra, they can get it from a renewable resource. So solar thermal, that is very small in Canada now, because the economics, since you can't put it anywhere in the summer, are poor. But what they found in Europe, it changes completely if you have thermal network, thermal storage. So I want to emphasize that there's many different sectors that can benefit, but the big one right now is the nuclear side. And that's why I'm not necessarily an advocate of nuclear energy, but I am an advocate of really high efficiency. And we have the chance, that's the biggest efficiency opportunity in the province, right? Nobody thinks of that. They think, oh, we're just trying to push nuclear energy. No, just take the heat you're throwing away. So we spend a fortune upgrading building efficiency on buildings, and that's totally right, we should do that, but we totally ignore the inefficiencies of our power generation system. So it's kind of hypocritical in a way. So that if we started putting on our societal thinking caps instead of our building thinking caps or electric system thinking caps, we've got these enormous possibilities, and they only do it elsewhere. And so the sector coupling, that's basically how it goes, and it offers benefits. And in fact, if I could go into one little detail, is that if you have a nuclear or any other thermal electric power plant, if you take heat out of the turbines, you're not messing around with the reactor or the biomass plant or whatever. You're just talking about the turbine section. If you modified it to take heat out, you could sell it for about $15 a megawatt hour and you'd break even. Right now, the electric utilities budget on $100 a megawatt hour for new electricity construction. So the heat you could sell for, let's say $12, $15, and you would break even. the electric revenue would compensate for the electricity loss. Okay? Now, Markham District Energy, if they could get decarbonized energy, they'd be prepared to pay $45 or $50 a megawatt. So you've got this margin between 45 or 50 and let's say 15 to negotiate how you're going to share the margin, so that if the electric utility can sell the heat at more than this break-even price of about $15, they actually make more money, okay? And the thing we're working on right now is that if they could sell that heat at, say, $50 a megawatt hour, that's kind of upper end, they wouldn't have to charge for electricity. Now that's a kind of extreme, but I just want to point that out. We're working on that. And so that if you could had the thermal network, if you had the thermal storage, then you could do something like that. And instead of everybody being afraid of soaring electric prices, we might look at stable or decreasing electric prices while also having a decarbonized and affordable heat. So that's the big challenge we're trying to put out there. We're trying to get the hook into the policymakers to start thinking about this, trying to get utilities to get comfortable getting out of it. Just briefly, if I may, I'm also the deputy chair of the Energy Task Force for Ontario Society of Professional Engineers. And we have agreed among this group of engineers from every sector you can think of, that thermal networks should be our priority for 2026. So we're meeting with the government on the 23rd, promoting our vision. So that we're getting people out there that understand it, and we're going to be pushing at all levels. I'm also doing work with Atomic Energy Canada, the Canadian Nuclear Laboratories, and they see the same challenges. Heat prices going up, possibility of selling heat, recovering it. So if we can keep working and get this vision that's strange to Canada but standard elsewhere, we could make a really big difference in Canada. So that's it.
That's great. Let's talk about that vision a little, because we've talked about Canada as a policy locale, but we've also talked about the impact on sectors. I wonder if you could maybe present the vision in terms of the urgency today, what needs to happen in the next few years, and then maybe space it out 10, 20, 30, 40. Yeah. What's the ultimate vision in terms of time? Yeah.
This is where you got to be flexible and creative, because every community has different opportunities, different densities, so forth. But the first thing is, I think from the potential sources of energy, these things don't have to be done in sequence, but if the power generation people said, we will make our power plants CHP ready, that is, they'll just spend a bit extra money to, say, put extraction ports in the turbines at the right places, leave space for heat exchangers and piping. By the way, a recent study by the UK energy people think that might be an extra 2% on the cost of a nuclear plant. Okay? You look at the overruns and everything, 2% is nothing, right? So if they built them this way at the design stage, it would cost a negligible amount. And yet, if a heat load materializes in the future, they could connect it up and serve it, okay? So get our power plants, whatever kind, nuclear, biomass, whatever, energy from waste plants, get them CHP ready so they can just produce electricity today, but at some point in the future, they could pick up heat without problem. And then for the communities, get them into thermal energy planning. This is a legal requirement in the European Union now. Every community over 45,000 has to have a thermal energy plan, okay? And what they found, talking to some of my German colleagues, when they take a new region, they found out that roughly 60% of the buildings can be decarbonized most efficiently through thermal networks. So anyhow, so get the communities, regions to think of thermal energy planning and think in policies how it all fits together. There's other big emerging things like data centers. They could be set up with their own separate little power plants and recover the heat from the power plant that keeps the electric load down, operate the data center, take the heat recovered from cooling it, and put it into thermal storage or in thermal systems. And then the next thing is we got to get the government policy-wise to at least have a positive view, saying, oh yeah, we acknowledge that would be great, you know. And there are policies that really help out, like the Danes, they saw this possibility. So now you have to, if you want to build a thermal electric power plant, you have to build it of a scale and location where you could use the heat and everything else. So there's a lot of variations on that our policy people could do that would be out there. We also, by the way, need the senior government people to do more serious analysis on that because they've got none right now. This is not even on the radar screen. They say they're using these great models, but our modeling people know the models they use have no way of looking at this, right? So we got to challenge them to use up-to-date concepts and models. So anyhow, so what you'd do, you'd end up with potential sources of heat being ready. And this includes, by the way, in the industry, start alerting them to the policy that instead of having their own cooling equipment, they could actually sell the heat to communities. Energy from waste plants, same thing. So get people thinking about the system, comfortable. And then from the thermal side, you've already got some district heating and cooling systems like Enwave, it's the biggest one in North America, in downtown Toronto, Markham District Energy. There's a number of others being planned, but get them to think bolder about building out and expanding. And if they knew the power utilities were willing to sell them low-cost heat, that would act as a catalyst to get them to think more seriously. But right now we've got a chicken and egg situation. Power guys say, well, where's the heat going to be sold? And the heat guys say, well, where are we going to get the cheap heat from, right? So if they cooperate and we're aware of each other, that could happen. So anyhow, so you get thermal sources planning, how they would fit together, the thermal sources, the thermal network people thinking, and starting to build out, including thermal energy storage. If I just take a segue on that, in Finland, they have a cavern storage, store hot water, and it can store 90 gigawatt hours of heat in this 1 million cubic meter cavern. And that's enough to heat a small city for a year, okay? And it's cost effective, it's about 2% of the cost of batteries, right? We have nothing going in Canada, except that Okotoks had a technical demonstration, but the scale was too small, so it's being closed down by the gas company. You also have a company in Toronto that's been working on borehole thermal energy storage, and they can actually go into an underground parking lot in downtown Toronto with only 7 feet clearance, 2 meters and a bit clearance, and drill down 200 or 300 meters and put U-tubes in. And so you could store energy in the earth below your parking lot. This is a real incredible breakthrough, right? So thermal energy storage. So you start building out this thermal energy storage in the short term. It could serve just local heat loads, even start doing solar collectors on buildings, put it in there. But later on, as long as everything's compatible with your powerful long-term vision, you can use the thermal storage today to capture and use local heat. Later on, it connect into something bigger. And as I said, you do the power plants, CHP ready. They just operate electricity only like they already do, but in the future they could connect. And then the next thing is the integration. In Denmark, they set up a Central Heating Transmission Corporation to look at linking things. So you need big picture thinkers that can imagine even going as far as Wesleyville, but certainly Darlington, Pickering, Toronto, Hamilton, to build this big energy transmission corridor to do it. In China, there's one example, excuse me if I ramble a little bit, but in China, they're taking heat from a nuclear plant to desalinate water because they're short of fresh water in the interior. And they take that hot desalinated water and they transport it as far as 125 kilometers. And then once they get to the city, they take the heat out and heat the city. And then they take the water, the cooler desalinated water, put that in the water supply. So instead of 2 pipelines, supply return, you got 1 pipeline, and you're getting revenue from the water and getting revenue from the heat. So this integrated thinking is incredible. And this is the other thing. So that I've been talking to there's people like pension funds, I've got people who work with them, and also recently people like Cooperators Insurance that make big investments in renewable energy projects and encourage it to their policyholders. We'll try and get them more interested to understand this and drive that. So once we get a critical mass of people in the industry, insurance companies, investment funds doing it, we've got big Canadian consultants now like Hatch, FEB working together. I think we're approaching at a critical mass where the policymakers start scratching their head and, hey, what's going on here? So that's what we are hopeful for. So the sector coupling, I think, is a key.
Yeah.
And so if you talk to people about thermal networks, they kind of look at you, oh, what are you talking about? Even district heating, and, oh, is that the old stuff where they made steam and inefficiently distributed heat or whatever? And so people's eyes glaze over when you talk thermal networks. But if we talk about affordable electricity for the future through sector coupling, people's interest picks up a lot. Right? So anyhow, so the sector coupling is going to be really important because it will enable things in addition to the thermal side that are going to mean a lot for Canada, mean a lot for Ontario. So that's where we're
where we're at and where we're heading.
Yeah.
And it seems like you're pointing to changing our thought patterns.
Yeah.
So it leads into this change management idea where we need to change the way we think about systems.
Yeah.
So I guess how would you approach that as a holistic thing?
I think the first thing is that our messages, communications, too often all of us, we're technical people, so you have a technical explanation, or we're economists and talk about the business case. But as you were saying, Jackson, the real challenge is change management. It's getting people comfortable with change. And that requires different language, different arguments, because you've got to reach out there and you've got to hook them. You've got to get them to say, holy crow, what my friend in the nuclear business calls gobsmacks. We need gobsmacks, where people hear the story, they're satisfied that the rationale is good, and they are gobsmacked. So our communication has to change, and you can't do it as an individual group. You've got to pull it together. Okay, so if we're going to have these integrated, powerful gobsmacks communication, then we need to develop a cadre, if you will, of people that understand that. Like any one of us, like Boltzmann Institute alone, that's not enough. So we got to reach out and get other people that share our end use, our end objective of a decarbonized, sustainable energy system for Canada. And they start looking for shared common interest, right? So you got all the environmental groups and the energy groups and renewable energy groups and everything else, but often they're all crafting their own story, their own pathway to the future. And they're often kind of seem to be almost fighting with each other. Hey, I got a better idea. And we end up eroding or confusing the public, eroding confidence in where we're all trying to go. So we've got to get an integration of that and develop, revolutionary terms. It's like a cadre of revolutionary people that can carry that message and communicate a lot of us rather than just one or two groups. Then that's going to be important. And then we've got to appeal to the self-interest, because electrical people think about the economics of their system, but they didn't think of how that would change if you had heat revenue. So you got to come up with that story that has the credibility with them and say, ooh. Because if our customers knew that there was a way of keeping electric prices down, and we said, nah, not in our mandate, which is what OPG said to us, we got a problem. So we got to create the communication that will make them think, oh, maybe we better look at this, right? And again, it's integration. Same with heat people. If they think we got to use natural gas to heat up the heat and distribute it, it's a hard sell because everyone wants to decarbonize and prices are going up to a problem. But if they could understand better that they could take heat from power plants of whatever kind or heat from industry, and if the industry was willing to do it, whether it's industry or utilities, then that would create a powerful message for them, for the thermal people, okay? And so I think that's the next part, is the communications are going to be critical. And then next, you've got to take that and show a building consensus. We got a challenge. And if it's not happening within government, we've got to create a critical mass outside that portrays it. And once we do that, then the government will start coming along and changing, right? If you can't persuade them, scare them. And so that's where I think we're heading, the big challenge we got today. And so that's kind of more or less what I see as the communications end. It's thinking a different way, thinking in a more integrated way, thinking of who's going to lose by change, think of what opportunity there is from them. Just briefly, we've been trying to talk to the gas industry. They're at risk of having a lot of stranded assets because everybody's thinking, what else do we do other than go to heat pumps, for example, or whatever. So the gas industry is going to progressively lose customers. What we're saying to them, you have a customer base, you have expertise, underground infrastructure. If you could change, you don't make gas. If you could change from buying and selling gas to buying and selling heat, you keep your customer base, you transform your business, and you would be the champion for Canada for our decarbonization plans. Because, and they're saying, oh, it sounds good, but, a little bit scared. However, in Quebec, the Quebec government said no more gas. We're committed to decarbonization. And they're thinking mainly electricity, but not necessarily constrained to that. So that Enbridge Gas Quebec, the Quebec wing within just in Gatineau, they are now looking at, since they can't do expansion of gas, they're looking at talking with local paper mills and a chemical plant to take heat, capture it, store it, distribute it, so to look all the communities east of Gatineau and put them on this. And they are seen as like a think tank for Enbridge, Ontario, right? So that if they do a good job of this, and we're working with them to help them as best we can, then that might affect the thinking elsewhere. Because the electric industry has a real problem, right? They're not going to be able to meet the requirements of electrified heating. ISO is allowed for 8% of building heating on it. The gas companies are threatened with stranded assets and erosion of business. And as your demand goes down, prices probably go up, right? And they could be different. So we got to look at the losers or the people who could be negatively affected. and think about them and think out how we can create opportunity. So that's the other big part. So we have to think of change, think of what the implications of change will be, who's going to lose, what the new opportunities might be, and then think of the change not just in economical terms. We're overly fixated on that. What's the bottom line, the payback, blah, blah, blah. And it shuts off a lot of creative thinking, right? And now we dump the carbon pricing. That's making it difficult too. But there are a lot of people out there really serious about decarbonization. Pickering alone with thermal storage could heat all of the GTA, right? You could shut off all natural gas there, use heat, throw in the lake, heat in Pickering, generate new revenue for the electric generators, stop the cash flow out of the province for buying gas, right? Be more sustainable, because that network, even if it did start based on nuclear opportunity, once you got network, can take all kinds of stuff, right? So then, if we can move forward on that, create that vision, get people bought in, then we can do a good job, okay? So I think that's the main thing. As you said, it's a change management issue. It really isn't a technical or economic thing. There are challenges. I don't say it's simple to get people to change the way they design plants. It's not simple. But if the engineers coming up through your university, I've been working with Mark Rosen going way back on this kind of stuff. If you can start incorporating, and we'd love to help out incorporating coursework. We're with the District Heating Academy in Stockholm. They're helping Mohawk College develop a curriculum, but they'd like to reach out more. So if we can do something here at this university, there's an opportunity to do that. If we can create new research opportunities, I think the university is committed to dealing with big expansion in nuclear. If they could have a broader understanding of what that future could look like, that'd be really important.
I'm glad you bring that up, and I wonder how important it is in terms of change management to get young people on board, and how much of your energy now is focused on getting young people to...
I would have to say that if you've got a small group of people, but our network is enlarging, you have to try and figure out what are the critical bits. Who are the key influencers you've got to influence, right? So we have done some work, like with McMaster University. They were using graduate students and some undergraduates to do work on thermal storage and other aspects of sector coupling. So we have had some engagement with students, but we see that to have the kind of capacity we're going to need, whether it's all nuclear or thermal networks, we have a massive capacity requirement, right? And so we would like to expand our contact to young people and professors, teachers on this. And so I think we make that as a big part. So I was talking to Jackson that maybe if we can take what we're going to be with OSPE, I should mention this, OSPE, the Ontario Society of Professional Engineers, we've agreed now that thermal networks will be the big priority for this year in our advocacy work. They have agreed to take the lead in doing sector coupling contract for the IEA. So we take Canada, take thermal people, electric people, talk about sector coupling, what it can mean, get more people comfortable with it. And then with Mohawk College, we're looking at courses. So if we could transport some of this here, maybe either integrate people here into the sector coupling workshop we'll be doing in Toronto sometime this year, or do a parallel thing, kind of replicate it. Take an example of what we're doing with the people in the utility business, thermal electric policy, and say, okay, here's our model, here's how we structure the discussion. Why don't you try that among students? And that would be a really creative thing, maybe give course credits, who knows. But I mean, I think that would be really great. So if we can create first of all, be challenged. We want you to challenge us and say, is this all BS or, is this real, right? Satisfy us that this is valid and real. Next, if it is, and agree on the possibilities, then okay, what can we do? If this is really an opportunity, we should be doing something. So test, kick the tires, think about it, and agree. And then if it is, then what could we do? Whether it's a special workshop session on sector coupling here or class projects, that would be good. Integration with some others, maybe even networking. We got a good network of people, consultants and other planners that are working in these fields. Maybe we can build some networks of people talk to each other. So we haven't got a fully developed strategy yet as the Boltzmann Institute or as the Ontario Society of Professional Engineers, but we're both committed to doing what it takes for change management to support it. Okay? So I welcome, Jackson's got my card and I got some more in my pocket, but if you've got any questions, if you've got ideas on how this could happen, let us know. And anything we can do, and that may include fundraising with government or whatever, to introduce this kind of stuff. Once you're satisfied that it's worth introducing, we'll do everything we can to help out, both OSB and Boltzmann Institute. And now we've got major consulting partners working with us for doing international work on this stuff.
No, that's great. And that seems like a nice natural close to our conversation, but I do want to give you an opportunity to maybe plug what's next for the Boltzmann Institute and what people should look out for with you guys specifically, but also with thermal energy networks.
Well, maybe let's say specifically the Boltzmann Institute. So we got a bunch of old retired guys working together and put a lot of hours into this stuff, and we're gradually building our network, but we're not going to be around forever. Two things I like to say about us is, one, we got a lot of flexibility, just like a professor on tenure, except our tenure is we got pensions, So we have a lot of flexibility, and we appreciate that. Not everybody does. Secondly, I'd like you look at old retired guys like us as a renewable resource. Sure, we croak, but there's lots more coming, right? But that's not enough. We've got to reach out and build capacity. We've got to pass the torch to a younger generation. So we're kind of working our way down through, managers and stuff like that in these sectors, but we got to keep on going down. And so we're not sure how to handle it yet, but we're just trying to, we've got informal members with a lot of experience that work. So in addition to a core of directors with a lot of different experience, we've got other people come in as members, network, and now we're starting to try and get younger people involved that are like in the electricity distribution business, get them engaged to put on thinking caps and help out. And then we got to think of maybe student chapters, student memberships. That might be good. And so anything we can do to explore that, see what the synergies are, what we think is possible, and what we can do to pass the torch, as it were. And then your understanding of students and the challenges, what makes them tick, what gets them excited, your input. You have all kinds of knowledge in that we don't have. We were students once, but anyhow. But so if we can get a meeting of the minds on what you think would be worthwhile, whether student membership chapters or whatever else, special workshops to mimic some of the work that's been going on elsewhere. You name it, we're open. And there's only so many hours in a day, so we have to be selective. But I think this is a really big one. And now I'm satisfied we've got enough other people outside our old guys network that are willing to commit to this and really interested. So if the demand's there, we'll find a way of meeting it.
That's great.
And then Boltzmann, And we don't necessarily have to have a Boltzmann Institute. It's just right now, I was a director for the International District Energy Association, but it's a US-based group that's kind of focused on what its members want. And the members are largely right now older steam systems. And so we have to think about more modern what's happening in the world, moving from used to be steam down to lower temperature hot water, because it can do a lot more stuff. We need to understand. I think we are filling a void. Unlike we're dealing with thermal planning, nobody else is really pushing thermal planning. We're working on interaction of the thermal and electric networks. I don't think there's a lot of people working on that. We're working on making long-term renewable energy more affordable, electricity more affordable by integration. Nobody's working on that now. If other groups pick that up that are better organized than us, fine. Our objective isn't to keep the Boltzmann Institute going forever. We'll make sure this void is filled and that it can be looked after in an effective way. So until that happens, we'd like to keep ticking along and see what we can do.
That's great. Good. Thank you so much. And on that note, we'll wrap up our fireside chat. I just want to thank Michael so much for coming, delivering a really interesting talk. I think we can all take some points home with us, and hopefully we see an expansion of this in the near future. So thank you so much, Michael.
Yeah. Thank you very much. Thank you. Yeah.